Hey everybody, Mr. Judson here. So here we are, our last day of review before our Central Washington final. I think I still have two people I haven't heard from yet, so I'll probably start making some phone calls. Anyway, chapter 5 and 6, we kind of combined those two. That's where we looked at derivatives of or integrals of e to the u and things involving natural logs, our inverse trig functions. And then also solving differentials. So let's go ahead and take a look. All right, so let's go ahead and see if we can solve this first integral. All right, so this looks like the integral of e to the u prime dx, and that just equals e to the u plus c. So if I try to rearrange this a little bit, let's say I've got the integral of e to the x cubed plus 1 times x squared dx. The derivative of this would be 3x squared. And so what I need to see in here is a 3, so I'll put 1/3 on the outside. And what we said is, if you see e to the u and the derivative of that exponent, written right here, then whatever this is, that's the answer. So that must mean this right here is my answer. So I've got 1/3 e to the x cubed plus 1 plus c. There it is. They don't have this formula written this way on the front cover of our book. It says e to the u du, but u prime dx is the same as du. So if I was going to write it down, I'd probably write it like this. All right, let's try another one. All right, you guys go ahead and try this one right here. So when you look at that, to me that looks like u prime over u dx. Again, it's not written this way in the front of our book, it's just written du over u. But this way makes it a little bit clearer. The answer is natural log absolute value of u plus c. And so this looks like a u prime over u, almost. The derivative of e to the 2x is e to the 2x. Times the derivative of the exponent, so I need to see a 2 up here, and then it's just the natural log of whatever's in the denominator. So 1/2 natural log absolute value of e to the 2x plus 1 plus c. And I believe this is positive no matter what, so if we had our absolute value signs left off, then we would still get that correct. All right, let's try another one. All right, let's see if we can solve this. This is the integral of 1 over the square root of 4 minus 9x squared dx. So there's two different thoughts that you could have on this one. One is it looks like an inverse trig function, but someone might also think it looks like a trig substitution problem. And I believe you can do it either way and get the same answer. I'm going to think inverse trig function. It looks like a squared minus u squared, and that formula was this. If I have the integral of 1 over the square root of a squared minus u squared dx, that equals arc sine of u over a plus c. So the most important thing is deciding what's u and what's a. And so if I rewrite this, I'm going to look at it as the integral of 1 over the square root of 2 squared minus 3x squared dx. What I have to remember is I need to see u prime up in the numerator. And I don't have that right now. Derivative of this would be 3. So I got to multiply by 3. and put a 1/3 out in front. Alright, so then I'd look at that and say my u value is 3x, my a value is 2. My answer to this would be 1/3, that's the 1/3 that's out in front, arcsine of u over a, 3x over 2 plus c. Alright, try another one. Alright, you guys try this one. Alright, so this looks like an arc secant, and our formula for that is the integral of u prime over u times the square root of u squared minus a squared du. I think in the last one I wrote 1 up here for arcsine. Should have had a u prime up there. Make sure you double check that. I don't want you writing the wrong thing in your notes. This would equal 1 over a times the arc secant absolute value of u over a plus c. And so I just need to make sure everything's set up right. So let me rewrite this problem. I've got 1 over x, and here I've got the square root of 2x squared minus the square root of 3 squared dx. So that means my u value is going to be 2x, my a value is going to be the square root of 3, and what I need to see is I need to see u prime in the numerator. Well, the derivative of this would be 2. I don't see a 2 here, so I'll go ahead and put 1 in. And I also need to see my u value here, so instead of putting that 1/2 on the outside, I'll just put a 2 there. 2 divided by 2 is 1. They cancel and still have the same thing. And so now I could look at that and say that my answer is going to be 1 over a, so 1 over the square root of 3, arc secant of u over a, absolute value of u over a plus c. There's my answer. Alright, let's try another one. Alright, you guys go ahead and try this one. If you can't read that, that's 4x right there. Negative x squared plus 4x. Can't wait to be done with these pens. Alright, so I think when I wrote down the arc sign earlier, I had a 1 over all this stuff. It needs to be u prime over this. So, again, just make sure you have that correct. So to me, this looks like one where I'm going to have to complete the square. Because I'm subtracting the x squared, that's what makes me think I'm subtracting the u value. And so let's see, I'm going to start by moving that 2 to the outside. Inside my square root, I've got a negative. I'm going to factor a negative sign out of each of these. So x squared minus 4x. So if I distribute this back and bring the 2 in, I'm back to the original problem. So now I need to complete the square. So half of this would be negative 2. Square it, you get a positive 4. I really just subtracted 4, which means I need to add 4 here. And so now what I have is 2 times the integral of 1 over the square root of 2 squared minus, this will be x minus 2 squared dx. So my u value is x minus 2, my a value is 2. If I take the derivative of this, that's 1, that is what I have in the numerator up here. So I can go ahead and answer this question. There is no 1 over a with the arc sign, but I do have the 2 out in front. So 2 arc sine of u over a. So that'd be x minus 2 over 2 plus c. All right, and then chapter 6 was really all about solving differentials. And we did a practice problem like that on our practice worksheet from last Thursday. I got the answers for that already on my Sway page, so if you need to take a look at it, go ahead. One thing that's real important about the solving differentials, and I'll just tell you right now, Central Washington is more interested in the story problem version of that than they are, here's a differential, solve and get y by itself. Okay, so we really want to make sure we know how to do that. But the part where you write out, what that differential equation is and solve it, that's the most important part of that problem. That's what's worth the most points. I told you guys before that it's really a lot like a PERT formula. If you just went straight to the PERT formula and solved the problem, you get very little credit for that. Okay, make sure we're going through and solve the differential. And I'll even give you a study hint. You may want to look at some differentials where it's not like the Buffalo one, where the rate of change is proportional to the number present. You may want to look at some other stuff, where it's proportional to something other than the number present, or it's inversely proportional. Inversely means you've got k divided by whatever it is they're talking about. See if you can find some problems like that in Chapter 6. We only went through the first 3 sections of Chapter 6. Probably the third one would be the best place to look, or in the chapter review for that. But I'd try and look at that. All right, so here is our last review assignment. Because it came from Chapter 5 and 6, that's why I have a couple different pages here. But again, just tried to pick out some decent problems for us to practice. So page 400, we're going to do 53, 55, 86, and 87. On page 430, we'll do just 53. And page 441, 19, and 35. All right, so exam on Thursday. I guess today's Wednesday, so that would be tomorrow. Remember, I will put this in an email to your parents at 9:45 if you're taking the 10 o'clock test. Really important, you guys, you have 3 hours to return that to me, okay? So get it printed out right away. Sit down right away, get working on that. I need to have that emailed back to me by 1 o'clock. If there's any issues, technology issues or something like that, have your parents email me immediately. Immediately, and tell me what's going on, and we'll figure out an answer for it. But if I just don't hear from you until 3 o'clock, no, I'm sorry, you didn't follow the rules. You have to return this by 1 o'clock. If you're taking it at 9 or at 6 o'clock, it has to be returned to me by 9 o'clock. Okay, so the 6 o'clock test I will mail at 5:45. All right, that's it. Stay safe. That's our last video. I might throw one last video in just sort of as a goodbye, but that's our last video for learning something. All right, talk to you later.